Welcome to today's talk on visualization updates. We'll talk about some things that are new and that were introduced in versions 14.2 and 14.3, and we'll take a little bit of a look at what's coming in the future. My name is Brett Champion. I'm the manager of the visualization team here at Wolfram Research, and we'll go ahead and get started. In 14.2 and 14.3, as a big amalgamation, the major features for the visualization team included doing updates to support dark mode in the front end, work on incorporating model fitting into the visualization pipelines, working with the new tabular data structure to make it easy to create visualizations from them, improvements on how to control labeling of items and plots, a new option for controlling interactivity in visualizations, and several new functions. And in the future, we have several other new features, which, being future-looking, forward-looking, are all subject to change, and so designs may change, names may change. We just may decide that we actually don't want one of them in its current form and do it into something else. Who knows? The future is unknown. So starting with dark mode, I'm not going to go into all of the details about dark mode. Noah Hardwick covered it pretty well in his talk from a general perspective and from a creating UIs and that sort of thing perspective. What I will say is that two initial things. One is a lot of the support that we had to do for dark mode in terms of choosing colors had already been done. When we were originally choosing colors, probably since version 10 at least, for plots and charts and whatnot, some consideration was how does it look on dark backgrounds? And so the palettes that the various visualization functions use by default were already chosen to look good on a light background and to look good on dark backgrounds. That being said, if you want to do your own styles, we had to do a little bit of work. So we had to make sure that light dark switched was supported in things like plot style, and that it flows through sort of everywhere that it needed to, and that was actually sort of where more of the work was. It was less in terms of how do we get plot style to work, but when I mouse over a curve and I get my dynamic tooltip that tells me what the coordinates are, making sure that that's using the correct styles. And so if we flip this over to dark mode, we see that this plot was generated with two light dark switched colors, one that flips between blue and cyan and one that switches between orange and red. And the interactive label call out that comes up switches as well, including the font color and the background. And in many cases, those sorts of features were where we had to put a lot more effort into supporting dark mode. I'm going to stay in dark mode for a moment. One thing to realize about light dark switched, however, is that while it acts as a color in terms of graphics and other places in the system, it isn't color Q, and it can't be used in functions like blend or lighter or darker. And so that makes it a little bit more complicated sometimes if you're trying to generate a style from other styles. And so it makes it a little bit more difficult, but usually it's not too hard to pull the light dark switched up and sort of further out in the structure. And so here we have a density plot that is using a light dark switched color function, and so it's or it's red to yellow in dark mode, and it's blue to cyan in light mode. And rather than saying that my color function is blend of two light dark switched colors, it is light dark switched of two blends. So we have our light dark switched, and then we have one parameterized blend for light mode and another parameterized blend for dark mode. So that's dark mode support in the visualization functions in a very short amount of time. So in version 14.2, we introduced tabular into the Wolfram language, which is a way of representing tables of data in a sort of structured way, in a very efficient way. And what we wanted to do is we wanted to make it easy to visualize columns from tabular in the different visualization functions. And what we came up with is a syntax using the rule character, using arrow, where you have whatever your tabular object is. So this one is, I'll go ahead and evaluate that. So we can see we have a lot of rows and several columns, and each column has different values. And so in this case, we're going to do a smooth histogram of the caret column for every row in this data set. And usually, there's a tight relationship between what the normal list structure of the input is, so list of numbers, and what the right-hand side of the arrow is. So this is a single column. This one's a list of numbers. Those are closely related. If we look at, say, list plot instead, we can plot caret on the x-axis and price on the y-axis. And this mirrors the normal XY pairs that you might have as a list of things in list plot. In 14.3, tabular got support for geographic typed columns, and so I think it's scroll, not move the window. So we have a column here that has latitude, longitude coordinates, and those came in this case as geopositions, and then they're stored efficiently in this table. And we can say that we want geo list plot of this tabular object, and we want the position column out of it. Similarly, we can do a geohistogram and see where all of these locations are on a map. Upcoming, we are redoing time series and event series to be able to leverage a lot of the work that's been done on tabular and to sort of use tabular under the hood. And in which case we have time series with multiple components, and the components potentially each have a name. And then we use a similar syntax for the visualization functions, where we use our time series in this case, which is browser history over time, or what fraction of market share each browser had over time. And so we can pick out the Firefox and Firefox and Chrome components and plot that in the same way, or maybe not quite exactly the same way, but similar to what we did for tabular. There will be small differences in syntax for some functions. For tabular versus time series, because in time series, the time component is implicitly there. It's always there. And so in the case of list line plot, we don't have to specify that I want time as my x-axis. So whereas if this was a tabular, this would be x and this would be y, because we have our x-axis predefined, then this becomes component 1 and component 2. I'm all scrolled over now. One thing that we added in 14.3 is support for plotting models of data directly from visualization functions. Normal is going to talk about this in more depth in about 50 minutes. And I encourage you to see his talk either live or watch the recording later. And so there's 3 main parts of this, a couple of new functions and 2 new options. And the big new function is list fit plot, where you give the data and it's going to give you the scatter plot of the points and then do a fitted model curve as well. And so in this case, we have a data set of different types of cars, and we're looking at displacement versus horsepower for them. By default, it's using some of the new model fitting mechanisms or functions. You can specify what type of model you want instead. So we can say we want a linear model, in which case we get a line. There's about half a dozen built-in named models right now. We're adding a few more for 15. And then the other option is a plot fit elements option that controls what we display and how we display information about the model and the fit of the model. And so here we're showing some 95% confidence bands, as well as the data points around the fitted model curve. At the same time, we also added a little bit more support for around in the visualization functions, in particular in plot and plot 3D. And so now you can say plot of an around expression, and it will give you your central curve and bands on either side of it. In 3D, you get band surfaces that were kind of tricky to figure out how we wanted that to look, so that you could see the band surfaces but still also see the central surface. And so opacity and less color, and also giving those surfaces their own mesh lines to sort of help you see how they're behaving in 3D. And similar to other functions that support around, interval marker style allows you to control the appearance of the bands. So change the color, turn off the meshes, that sort of thing. So for a long time, Wolfram language has had support for automatically labeling points in list plot, and it sort of by default tries to show as many labels as possible within certain constraints. And the constraints are, we don't want the labels to collide with each other. We don't want the labels to collide with points. We really only want the labels to show up where there's space and where they won't interfere with other things. And so that works really well, but there are times where you're willing to make concessions about things. And so you maybe want more labels and you're willing to allow a little bit of overlap, or things to get clipped or collide a little bit more than we do by default. And so we added an option called labeling target, which at its simplest says, I want to label, say, 25% of the points. And so then it will label 25% of the points as well as it can. And you'll see that there's some places where some things are overlapping, some labels are colliding. Labels are overlapping points, etc. And so that's nice and easy and straightforward. But it also allows an association-based specification with even more fine-grained control on various aspects of the labeling. So as an example, I can say that I want all of my labels to be on the sides of the points. So either to the left, to the right, above, or below. Um, so if you look at this one that we had before, you'll see that wannabe here is sort of labeled on a diagonal out of this point, whereas actual is labeled straight to the left. And so this allows you to say, I only want the straight left, straight right, up and down um, types of positions to be used. Or you can even say, I want the callouts to only go straight down, and label as best you can under those conditions. You can also allow the labels to get clipped by the plot range, which by default, if it determines that a label will get clipped by a plot range, that it will not show that label at all. I resized this graphic, and so it's a little bit harder to find, but you can sort of see on the left-hand side over here that I'm guessing that's, well, I'm not sure what that word is. But if it, was a word that had meaning to me in this data set, I'd probably still be able to recognize it and identify it, even though the first part of the word is clipped off. You'll also see that in this situation, the labels are being allowed to sort of get into this axis territory, where before that was being that was a restriction as well. So plot interactivity is a new option for cases where you don't want interactive behaviors. And so at its simplest, you say plot interactivity goes to false, and it turns off pretty much all interactivity. So normally plots have this interactive callout that gets turned off. Charts have tooltips and mouse over effects with the edges, and those get turned off as well. There's also a plot interactivity dollar variable that you can set globally or locally using block. And so I use this sometimes if I'm using different visualization functions to create a illustration or diagram for explanatory purposes, and the normal highlights would be a distraction or inappropriate for some other reason. And so here I'm using show to combine two plots, one plot with all the series approximations of sine, and one plot with the actual sine curve. And if I didn't have the interactivity turned off, then the sine curve would have its interactive tooltip, and collectively the series approximations would have a tooltip, and when you moused over it, both of them would fire and it would look kind of bad. And so in the case like this, it's easier to just turn off the interactivity, sort of in a grouping thing, and then if I'm building something up with 4 or 5 plot commands, I don't have to specify the option for every single one of them. There are also a few new functions that were introduced in 14.3. Two of them are surface contour plot 3D and surface density plot 3D, which take a function and plot it over a region or over the surface of a region. And so here we have a spoon, which I think we've seen lots of examples over the years involving this spoon. There's a bunch of PDE code buried here that isn't really important, but it's creating or calculating a stress acting on the spoon, or stress from the spoon being acted on by having weight applied under certain conditions. And so we can do a surface contour plot 3D of that stress over the spoon and see where the stress is the highest and where it's the lowest. And similar, we can do the same thing with the density plot. And so the other one that we added in 14.3 was smooth date histogram. And this was started sort of related to the current time series / tabular work, and it got done before the other parts did, so we went ahead and released it anyway. So this is similar to date histogram, except instead of using discrete bends, it's using kernel functions and a bandwidth and creating a smooth approximation. And so here we have launch dates for all the communication spacecraft that Alpha knows about. Then we can see that, sort of in the last few years, there's been a big bump in satellite launches as all the Starlink stuff and other global communication type things have come online. Similar with normal smooth histogram, if we use a larger bandwidth, things smooth out more. If we use a smaller bandwidth, things get bumpier and peaks get higher and whatnot. Let's see. So now we're getting, solidly into the future developments, current, things we're working on right now, coming out in a future version. One of them is plot grid, and plot grid is going to make it easy to combine plots in a grid, in particular in ways that allow the scales to be reused, which results in cleaner layouts. And so here we have a bunch of histograms, and you can see that the X domains are all different. So they go from -10 to 4 or -2 to 4 up to -10 to 10. The heights go from 60 up to 150, 160. And so we can create a plot grid of these where all the x-axes are the same and all the y-axes are the same. So that means that then all of these distributions, all these histograms are now comparable. We can relax that a little bit. So in this case, we have each row has its own height. It turns out that the first column is forcing the height in all of them, and they end up being pretty much the same. But each column has its own width, its own X range. And so everything in here goes from -2 to 6. And over here, everything goes from -10 to 10. You can do it the other way around, and so on. Additionally, we are redoing plot style and promoting chart style in bar chart and pie chart and that sort of thing to use plot style, so that you don't have to remember two option names. And so plot style becomes an option to all the charts, and that's also going to apply to plot labels, plot legends, and a couple other things that were charts options and now become plot options. Besides lists of lists, at the same time, we're allowing an association-based syntax so that you have more flexibility, which is really what the charts needed. And so here we can say that, each group we're specifying what the sequence of colors is for the groups. We can specify instead what the sequence of colors is for the elements in a group. We can say what a base style is that applies to everything. And this then is also going to apply back to the things that have traditionally taken plot style. And so you'll be able to say list plot, and I want the lists to be purple and cyan. I want those are two colors. and I want the base, I'm going to use the base aspect of this plot style to specify the point size for everything. Previously, if you were getting into this and you wanted this, you'd have to say, okay, I want plot style goes to a list, and the first element in the list is going to be directive of standard purple and absolute point size 7. And then I'm going to have another directive for the second element in the list that's going to have the cyan and repeat the absolute point size 7. And so this sort of factors out that type of specification so that you don't have to necessarily, I mean, previously you might have had to create a map to create the directive and have everything go out that way. And similarly for, plot, in this case it's functions, that we say what the colors are. And so I think I'm going to stop here and answer a couple of questions. And so let's see. The first question is there a way to force non-overlaps in the labels? That's from Michael Salami. And in terms of, it depends on what overlaps you mean and perhaps what function is doing the labeling. So by default in say like list plot, none of those labels are overlapping with each other, with points. They're not crossing the axes, etc. If you get into some of these association syntaxes, then there are additional controls that allow you to say how much overlap you're willing to accept. Are you willing to have 10% overlap between labels, but not more? And so that is a possibility. And then Jerry Schultz was asking the same thing, but for graphs. And graphs has room to improve its labeling. And it's a slightly different set of developers. But I think that there are things that we have here that have been done labeling wise, and even other teams like some of the geo sorts of things that could improve the labeling of graphs as well. And then final question, for plot grid, will you then be able to overlap them all on one grid with different colors for each by default? So plot grid with options, something like joined or composite. So and that's from Dorothy Evans. And I think if I'm interpreting that question correctly, I think it is less of a grid thing, but I want, let's go back down to here. I want to do the unified plot range, but then essentially do a big overlay of everything and show everything in the same plot range. And I don't think that will be in the scope of plot grid. But it is a useful concept to have a function for. Right now, you would use show to basically combine a whole bunch of graphics into one, but the resulting options, so like the plot range, the aspect ratio, that sort of thing, all come from the first plot that's being used. And so having something that's able to then easily recompute, say, an expanded plot range for everything would be useful and interesting, and is a direction for us to look at. So I'm going to stop here and thank you all for coming.